Before we go to spherical coordinates, if you have a point 1, 2, 3 in rectangular, how do we convert that point to cylindrical coordinate system? Now, we remember we say our parameters for Cartesian, rectangular is x, y, z. That of cylindrical r, theta, and z. So once I'm going to find r, theta, and z, I'm done. How do I find r? R squared is equal to s squared plus y squared. So I can use x and y to find r, and my r will be equal to the square root of 5. Z does not change. Z still remains z. So z is 3. Now theta is given by the tan inverse of y over x, and here y is 2, x is 1. So tan inverse of that will give us theta. If you compute that one using calculator, we put theta here. We are done. We found the point. We've been able to convert a rectangular coordinate point to cylindrical coordinate point. Next, let's do the reverse. If you had a point in cylindrical coordinate, let's take 3 pi on 8, 7. Remember, parameters are theta and z. It means that r is 3, theta pi on 8, and z is 7. We want to convert this to x, y, and z. Remember, z will not change, right? Z is still z. So here my z is 7. All I need is x and y. And we know that x is equal to r cos theta, y is equal to r sin theta. So this is given by our x, which is r. R here is 3. Theta is pi on 8. Still r3 sine of theta pi on 8. If you compute these values, right, we would have known x and y. We put them here accordingly, and we are okay. Good. We go to spherical coordinate. My favorite, spherical coordinate. Spherical coordinate. If we have a point in space, we want to locate this point as usual, right? Now let's connect this point to the origin. And let's call the distance rho. Let's call the angle it makes with the z phi. If we project this onto the xy plane and connect it to the origin, let's call the angle here theta. Theta. So here we say spherical coordinate is characterized by rho, theta, and phi. Where rho is the distance between the origin and our point in space. Phi, the angle it makes with the z. And theta, when we project the point onto the xy plane and connect it to our point 0, 0, the angle it makes with that. Now we know that this here, we call it r. Okay, we call it r. Right. Now, let's look at something. Let's see. From cylindrical from cylindrical coordinate system, right? We say x is equal to r cos theta, y is equal to r sin theta, and z is equal to this. Nice one. If this is z, I'm going to, I'm looking at this, the right angle triangle, right? Which is like that. If you can see clearly, if you can see like this and like that, with here R. Here we call it phi. And the distance here we call it rho. Okay, I hope you can appreciate that. Good. If you can appreciate this, let me project this one here a little. So here is still R, right? For the symmetry, this is still R. And I can erase this like that. Okay. Now, what can be said about this? Using SOHCAHTOA, right? Using SOHCAHTOA. Then, this one here is my adjacent. And this here, my opposite, right? Remember, it's the distance that is R, okay? The distance from here to here, I don't know. Let me call that one Z. I don't know, right? That is height. I'm not above it. Okay, I'm calling that one Z. But R actually is our distance here. We should note. That one is R. The distance is what we call R. Okay. Now, if I want adjacent, from SOHCAHTOA, adjacent, which is there, is equal to cos, is equal to my hypotenuse, which is rho, times the cos of the angle phi. And my opposite, which is R, is equal to hypotenuse times the sine of the angle phi. Okay. Having said that, let me substitute Z and R in this equation. Then I'm going to have S is equal to R is rho sine phi cos theta. Y is going to be rho sine phi sine theta. And Z is going to be rho cos phi. Remember, R is important. R is equal to rho sine phi. Okay. Okay, rho sine phi. Good. Having said that, let's see. So if I have a point, I must be able to convert this, a point in spherical to cylindrical, and cylindrical to spherical. And if I can convert a point to spherical, or sorry, cylindrical, then it will be easy for me to convert it to rectangular. Right? Okay, now, given a point, let's see. Oh, I'm not done with this. Let me finish with this, right? It can also be said that x squared plus y squared plus z squared is equal to rho squared. Theta still remains the tan inverse of y over x. Right, nice one. So let's see. Given a point, a rectangular, let's say 1, 2, 3. All I need, I'm supposed to convert this to spherical. All I need is rho, theta, and phi. And I can get my rho straight, right, from here. Rho is s squared plus y squared plus z squared is equal to rho squared. So the square root of s squared plus y squared plus z squared will give me what? Rho. So my rho is just, my rho will be just the square root of 1 squared plus 2 squared plus 3 squared. Right? I can get my rho from there. Okay, next, I can talk of theta. I can talk of theta, where theta is equal to tan inverse of y, which is 2 over 1. So theta will be given by that, right? Tan inverse of y over x, right? Then next, I can talk of phi. Now, always use this equation for phi. It's important. Don't use the r. Okay, use the z for r. Now, I say that z is equal to rho cos phi. What is my rho? I've computed already. Now let's just do this. This is 9. This is 4. So with 14. So rho is with 14 cos phi. But what is my z? Remember, from here z is 3. So from here I can find phi. So phi will be equal to the cos inverse of 3 over the root of 14. That will give me phi. You understand? So I can do that. Let's look at the other side. Let's try to convert a point also from spherical to rectangular. If I'm given 3 pi on 4 pi on 3, then, and I say this point is rectangular, sorry, spherical, right? Then this is rho, theta, and phi. I need x, y, z, and with these 3 equations, x, y, and z, when I put rho, theta, and phi appropriately inside, I can compute x, y, and z. I hope that one is clear. Once I can convert this to rectangular, then it's easy for me to bring it to cylindrical. Even if I were asked to convert this to cylindrical. What is cylindrical? R, theta, and z. I can use this equation to find z. Another equation to find theta. All I need is r. And from here, I can find r. I can find r because I know what rho is, I know what phi is. I can find r. I hope you understand. That should not be a problem.